We are getting close to summer, the time for shorts, and that's exactly what we've got here in front of us. So on the bench in front of us we have this little gadget, and this is the Gearbox controller from an Aston Martin. I couldn't tell you which one. It'll start with DB, or the name starts with a V. That's about as much I know. I'm sure I could look it up. But we have some issues with this. So I already know that this thing doesn't work. It was opened up, water got inside it, which is fairly common, and I have seen some that have been a hell of a lot worse than this one. But we had, well, I suppose it had been cleaned up by someone beforehand. It still wasn't working, and we did come across some bits and pieces. So there were a few bits. I guess the water was happening sort of more over this edge. This particular resistor was quite heavily rusted, and it was taking the job very seriously, as it wouldn't let anything go through it. So maximum resistance. So that's one we had to swap. That was just I think a 1 kilo ohm resistor. There's these couple of ones here are rusty. At least they were rusty on the end caps, but they are still working fine the way that they should. Some of these other capacitors as well, you know, the solder was looking a bit grey, so I cleaned up, well, at least I resoldered that and re-wetted them, and they kind of seem to be doing what they should. Some other rusty connections here. All of these pin connections were quite rusty. In fact, there is still one in there. I wonder if we can catch him on the light. This one, he's quite black and going out to there. So that might have been where some of the power was coming in, as that's the kind of corrosion you get on something with power. But anyway, back to the case at hand. After swapping the resistor and going through and looking at all the other capacitors, making sure we didn't see any cracks or chips or anything else standing out, I started then just to check a few of these capacitors, which had the kind of the grey matte sort of corroded solder on them, and I started finding shorts all over the place. So some of these were shorted, some of these were shorted, some of these were shorted. And that's telling me that something on this is shorted, and that's what I need to find out. So somewhere in this board, there's a short, and we need to go hunting for it. So to show you what I mean then, let's get this multimeter on it. So it's got it set on beep, and let's see if I can do this down through the camera. See, that was the one I checked first. It's like, okay, right, we are reading. In fact, if I can get a good contact there. That's showing me 0.9 ohms. Now, to be honest, some of that is the lead, because if I go there, I read back 0.2. And then we go to some other capacitors. He shows as shorted. Focus goes all over the place. Let's come back. Shorted. 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 Stay in focus. Shorted. So a lot of these are showing as shorted, and that means I guess that something else on this board is going to be one that's shorting it, and it's tying a lot of this stuff together, and that's going to be causing our issue. Now I know that these little silver lugs on the back are grounded, as I can go to some of these, and if I go over to, I think, this side of a capacitor, and there, so that's a ground plane, and again you can see that from its kind of layout, but at least we know now that that is a ground that we can use as just a reference. I know I can always go onto this part and know that gives me a ground, but we go onto these capacitors and it's not shorted to ground. So we have a short on these capacitors, but it's not a short to ground, so it might be a short to power. So we're going to have to try and figure out now where that is. So from what I can tell, it looks like there is multiple grounds, as although we have one ground that does track around, as a kind of a ground plane. That looks like it's going to be almost like more of a shield. Now I do see obviously some bits and pieces, so there it is, and we do have a capacitor over here that taps into him, and he doesn't show anything. So there is going to be some other ground, and this is one of the reasons why I know that, as this is a 5-volt regulator. It'll take the 12 volts in from the ECU, from I suppose the car, drop it down to 5 volts, and that's going to be powering other bits and pieces, possibly direct into that processor at 5 volts. I think that chip, this flash memory chip, is going to be 5 volts. But we certainly have, if this will stay close and focused, a short between those two legs, and that is that middle pin there again is a ground, and this outside one is meant to be the output. So something on the, I guess, the 5-volt rail is shorted to ground, and we can also track that ground down if we go all the way over here to these other chips. These are going to be ones that control individual solenoids inside the gearbox, so there's going to be a few of them there. Torque converter lockup is going to be in these. So this is the output section, which is going to go through and flick various different valves for all of the black magic that goes on inside one of these automatic gearboxes. But we can see that I suppose our ground is that one, but our power is still shorted to it as well. So the first thing I'm going to do, I'm going to try and remove this 5-volt regulator and see if that is our issue. So these can be awkward to unsolder, as they are on quite a bit of a heat sink to take the heat away. Because it's dropping 12 volts down to 5 volts, it does generate a fair bit of heat. And you can see all these little via holes there, it's stitched through. That is not for power, that is for heat. It's to conduct the heat through into this copper trace, and the copper trace through onto the other side. So to get this off, we're going to need solder and the hot air station. I'm going to have them both heating up, and one thing I'm going to do as well, I'm going to load a load of solder on this back tab, have the iron on there, and that hopefully then should conduct a bit more heat through into that, and we'll get him off. That was a lot easier than I was expecting. Managed to get that off. I do see I've knocked a little capacitor there, so I'll have to get him stuck back on, and then we'll check again for shorts. So I stuck our little capacitor back. That was that guy knocked in there, sort of pulling him off. But let's have a look now if I can unknit my cables. So here are our two pads. Right, and we still have a short, and we are showing, what are we getting? 1.3 ohms just there. Can I make it any lower? 1.1. So something still is shorted on the board, and it wasn't the 5-volt regulator, but it's going to be something else on that 5 volts that is shorted to ground. So let's see if we can figure out now where that is going to be. I have gone through some of the easy stuff, things like diodes, and we're not getting anything on there. But for example, this is where things get tricky. So we're showing a short across this capacitor, and it's like, well, okay, maybe that one's shorted, but I know that this goes from one of these sides goes to power, and I'm reading, what's that going to be? Get him to read 0.4 ohms. This other side then goes to ground, 0.4 ohms, and then between the two, 1.1 ohm. So there's something else on there with about a 0.7 of an ohm short between them, and that's the thing that we need to find. So diodes was an obvious one. It's not that. It's not these chips either. It's not this big transient suppression diode sitting here in the middle. He's actually still working as he should do. So something in here is shorted, and what I might need to do now is try voltage injection and look and try and see what gets hot. So I've got some wires added on now where the regulator was. The yellow wire going in is the ground and the red is our power. Our power supply at the moment, our little mini one, is set to 3 volts and 500 milliamps. So let's hit it and see what happens. Okay, it has dropped down to 1 volt, but I don't really see anything heating up. Maybe there's something over there. I think that's the wire though. So let's cut the power and see if anything has turned up. So I don't really see too much heating up. All we have is our input wire at the end of that, so it hasn't really shown up anything too interesting. Let's have a look on the other side of the board. Okay, we've got him flipped over now, and let's connect the power up again and let's see now what we have. So again, that has dropped, but I don't really see anything heating up. So I think we need to go, oh, we have got something. Right, that is just there. Okay, maybe that's our guy. Let's go again and let me see if I can hook this on one-handed. There we have a bit of a hot spot. So there is something going on just there. Let's see if we can zoom in a little closer. So we seem to have one capacitor just in that bottom corner. When I hit the power, we see in there heating up on the thermals. So I wonder if that's going to be our guy. Cut the power and he will start cooling away. One of the things about these thermal cameras, obviously they show temperature, not color. So when everything is the same temperature, nothing really sort of shows up on the screen at all. But we hook him back in and I instantly see how the color changes as it is kind of auto ranging. So it's in these like blues and greens when everything is all at the same temperature. As soon as it touches, starts to auto range, and we see that little capacitor there warming up. So let's try and get him off and see if that is our short. So let's just show you what I'm on about. It is this capacitor here. So again, this one was pretty grey and corroded on the solder, and I did then reflow it to make everything look nice and shiny. And one of the first ones I tested and said, oh, that one's shorted. Then I checked some other ones, that one's shorted, this one's shorted. So it might be that that happens to be the one that was shorted after all. And to be honest, it is on the side with the rest of the damage and the damp. So I am going to unsolder that now and see if our short goes. And there is our resistor off. Let's see, does he show up on the thermals really? He's cooled down a bit now. But let's now check and see what our short is doing. Right, so let's have a look now and see between our two connections. Yeah, and that is it. So there's our beep when we're on the same one, and now between those two our short is gone. So that was our short. Tricky thing is now I don't know the rating of that capacitor, so I might have to try and figure it out. I do have some other boards around. I'm going to try and see if I can find something similar, and if I have one with the similar kind of connections, a similar resistor or a similar capacitor in the same spot, I will check that one and see what that one is. Well, first try was this E39 one, and you can see They are very similar in design, but over here in this corner we don't have a capacitor hiding here. So I do have another Aston Martin one, but to get into them you need to cut a whole bunch of aluminium rivets to get in. I'm trying to avoid that at the moment. I'm going to see if I've got anything else, another BMW one again that might be closer to this one, before we go nuclear and pull the other Aston one to pieces. I hate those aluminium tabs, so I've already just stabbed myself in the hand trying to get this one open. I thought, well, this one we have the single 88 pin plug, maybe will be similar on the inside, but this one though completely different to the one we had before. So I don't have much hope of this one having that capacitor in that same spot. This is one that's kind of like a completely different architecture. We've got an EEPROM chip inside this one of these little ceramic hybrid modules, same sort of thing we saw in the Mercedes video, if you've seen that a couple of weeks ago. And yeah, we've got relay, so this is a lot older than the Aston one, so I don't think we're going to find much similarities in this. So while I'm waiting to hear about our other Aston Martin and ECU and whether I can open him up and whether that's going to be cause any kind of an issues, I'm not 100% sure whose ECU that was. What we can do is we can put this 5-volt regulator back on, as we know that's not the issue. So I'll get that soldered on now and then we'll see what's happening. So that's our regulator back on. So how I tend to do these, I think it's TO220s, these ones with the tabs on the back, because those tabs are a heat sink, what I'll do is I'll clean off the leg pads first, but I won't clean the backplane ones. In fact, in some cases, I'll even move the soldering iron around till I get a little lump of solder in the middle. Then when I solder on the 3 legs, I can hold this thing nice and solid. This will be sitting up a little bit on that lump of solder, and I can then heat that back tab and the entire component, and then when I see it fall down, I know it has melted the solder underneath and it's touched itself down and making a solid contact. Then I can take the heat away, let it sit for a while until it cools, and then after it's cooled, I'll then go back over and just dab the soldering iron on these front legs again, just to de-stress them in case they were obviously put in at one angle, bent down, soldered, and then those legs have a bit of tension on. At least then you resolder them, they can release any tension. So he is back on. So all we need to do now is to find out what that transistor was. Sorry, not the transistor, capacitor. I've got the pad cleaned up and ready to go, and we'll just find now that capacitor and I'll show you it. So where is he? He is just there. So we're on beep, and if I can get a contact on him, which is pretty hard, there we go. So we have a dead short in that capacitor, the one we've removed. Now with things like the resistors, that's not really a problem because we've got colour bands on them, or we might have numbers on them. There's a 000, it's a jumper, a 102, 103 by the looks of it, 000, it's a jumper. But the capacitors don't really have anything written on them, and they could have a whole bunch of different ranges on those things. Judging by the size, it's not going to be a hell of a lot, but again, I'd like to get that to be exactly the same as what it was. Maybe it is just something minor, a bit of filtering, but it's one of those things. I'd rather not take the chance of just throwing anything in there. I'd like to get the right part in. So this is our spare board and we are reading 437 microfarads on that. I've already taken it off as well, just to check, because sometimes obviously you can have other stuff in there in circuit. And I found a capacitor. I have put that into our original one that we're working on, which is this one, and here he is down in the bottom corner. And if we get onto him, and it'll find the range, 431 microfarads. That's good enough for me. And the final thing then I want to do is I want to clean up this pin that looks a bit corroded. You see the solder's gone very grey around there. So I'm going to try solder sucker on that one, clear that one out, get some fresh solder, and same on that side. As I have gone through and I've dabbed these with the iron to remelt it, but it's not cleaning up as there's a lot of oxide built up into that lead. So let's give that a bit of a clean up and see what we can get it looking like. Well, it didn't clean up too much, but at least I know it is still continuous. So if I go down onto it there, which is this third pin, if I can find it, it turns up there at a diode down over that side, and we have 0.6 ohms. So, and again, that's mostly the leads, so I know that connection is actually all sort of working through. So that is it then. We are going to box this up, and I suppose next thing to do, plug it into the Aston, see what happens. So it went from obviously having major faults, we had rust, we had this blown capacitor as well, or shorted capacitor. We have them sorted, and it all seems to be behaving normally. So that's what we'll have to do. We're going to have to try this out on the car. So thanks for watching. I'll see you on the next one.